Okay, this is exercise number 13 in section 2.6, and practice with computing higher order derivatives. They give us a function x plus 1 over x minus 1 and ask for the second derivative. Okay, well, first derivative. Okay. Now the only way to get the second derivative is to get the first derivative and then compute its derivative. Okay, so what is the derivative of this function? Well, you look at the function here and you would say, well, I can use the quotient, right? Okay, the quotient rule says take the denominator times the derivative of the numerator. Okay, so x minus 1 times derivative of x plus 1, which is 1, okay, minus the numerator times the derivative of the denominator. Well, the denominator is x minus 1, so its derivative is also 1. Right, the derivative of x is 1, the derivative of 1 is 0. Okay. That's all over x minus 1 squared. Okay. So let's see what I have up here. Try to use some space in this area. I'm going to have x minus 1, okay, minus x minus 1. So I think minus 2 over x minus 1 squared. Okay, that's the first derivative of this function. Well, what about the second derivative? Okay. Well, you have to compute the derivative of the derivative. So I compute the derivative of negative 2 over x minus 1 squared. Okay, so that's what we have to do next. Okay, that will give us the second derivative. Now, just to kind of show you some things that I like to do when I'm doing derivatives like this, you've got a lot of flexibility with algebra and the rules of calculus that we have. I don't like the quotient rule, so you can actually get out of using the quotient rule in this one, okay, because what we really are computing the derivative of here is negative 2 times x minus 1 to the power negative 2. Okay, see what I did there? Instead of dividing by x minus 1 squared, I wrote that as times x minus 1 to the power negative 2. Now the reason I did that is because it gets rid of that quotient. Okay. Now when I compute the derivative of this, okay, what am I going to do? Well, I'm computing the derivative of something which is being multiplied by a constant. Okay, so it's negative 2 times, okay, now keep in mind here I'm working on the second derivative, so the second derivative is going to be negative 2 times the derivative of x minus 1 to the power negative 2. Okay, so what about that? Well, that's, of course, something I can use the generalized power rule on. Okay, so I get negative 2, and what's the generalized power rule say? It says when you take the derivative of a function raised to a power, you bring the power down, decrease it by 1, so now the power is going to be negative 3, that's 1 smaller than negative 2, and you have to multiply by the derivative of what's inside. Okay, so the derivative of x minus 1, again, is 1. Okay, so here's what I did. I just kept that negative 2 outside, okay, and then I used the generalized power rule on this expression. Okay. Well, I've got some simplifying to do, but I have negative 2 times negative 2, that's 4, times x minus 1 to the power negative 3 times 1, which of course doesn't affect anything, and I can write this just as 4 over x minus 1 cubed. Okay, so that is the second derivative of x, okay, the thing we were asked to compute.